Hi, my name is Rista Nicolae Cătălin and today I'm going to present our work, RoDia, a new dataset for Romanian dialect identification from speech. This is joint work with Codruț Rotaru and Radu Tudor Ionescu from University of Bucharest, Romania. Dialect identification is a crucial task in speech processing and language technology, enhancing various applications such as speech recognition, speaker verification, and many others. While most researcher studies have been dedicated to dialect identification in widely spoken languages, limited attention has been given to dialect identification in low-resource languages such as Romanian. Having more dialect-oriented data for low-resource languages could lead to improved performance for deep learning models and more inclusive frameworks. Our contribution is as follows. We introduced RoDia, the first dataset for Romanian dialect identification from speech. RoDia includes a varied compilation of speech samples from 5 distinct regions of Romania, covering both urban and rural environments, totaling 2 hours of manually annotated speech data. We introduced a set of competitive models to be used as baselines for future research. We manually transcribed our data samples to allow automatic speech recognition systems to be tested and trained on our dataset. And also, we released our dataset at the given GitHub link. Now, let's talk a bit about the Romanian language. We focus on spoken language identification in Romanian, a low-resource language characterized by its intricate dialect variations within the country of Romania. Romanian is a Romance language with Latin roots shaped by historical, geographical, and social-cultural factors. On the right side, we can see the country Romania. On the south part, we can find the Oltenia and Muntenia regions, while on the north part, we can find the Banat, Ardeal, and Moldova regions. Those are the regions where the given dialect is spoken. Now, let's talk a bit about the Romanian language and how we selected the dialects. We aimed to include as many dialects as possible. Also, we were limited by the number of audio samples available for dialects spoken in small regions. Thus, we selected top 5 most popular dialects which are representative for the regions depicted in the right-hand side figure. In the bottom part, we can see the table with dialect and the corresponding population. We can see that the first 5 regions are Ardeal, Moldova, Muntenia, Oltenia, and Banat, and the corresponding populations. Thus, we selected those dialects to be representative for the entire country. In the following slides, we will describe the dataset. Let's see the dataset statistics. We report the number of samples for each dialect in both train and test splits, as well as the signal-to-noise ratio, SNR, and signal-to-reverberation ratio, SRR. The SNR and SRR values are consistently higher than 23 dBs, highlighting that the audio samples have relatively low noise and reverberation. In the below table, we can see the class, which stands for the dialect, ardelenesc, bănățean, moldovenesc, muntenesc, oltenesc, the number of speakers, and the train and test splits. For each split, we can see the number of samples, the SNR and SRR. Also, the last row is the overall statistics. Here we have the overall number of speakers, samples, and the average SNR and SRR. As I said before, we can see that the values for SNR and SRR are relatively high, highlighting that the samples have a good quality. On the right side, we can see the data distribution across train and test splits. We can see that the number of samples is relatively uniform in accordance with the dialect for both train and test splits. Now, let's talk about dataset demographics. Our dataset exhibits a relatively balanced gender distribution, having 59.5% male and 40.5% female speaker. We can see the distribution, the pie chart in the right side for gender. Besides gender, we aimed for an approximately uniform distribution in terms of speaker age. We can see the pie chart for age in the right side. We divided the age in 10 years classes. More exactly, for 10 to 20 years, we have 5% speakers. For 20 to 30 years, we have 17.9% speakers, and so on and so forth. And aside from separating the speakers between training and test, we also made sure to have a similar demographics for the train and test splits, reducing unnecessary distribution gaps. Now, let's discuss the dataset acquisition process. Firstly, let's talk about the source of data. We obtained the majority of audio samples by gathering interviews and shows from local TV channels from all 5 regions considered in the dataset. A small proportion of data was acquired by recording citizens native to those regions who were asked to read some random texts from Romanian Wikipedia in their own dialect. Regarding labels, all samples gathered from the TV channels were sent to local annotators to validate the assigned labels. This was done in order to eliminate samples with a questionable dialect. Aside from dialect labels, our annotators labeled each audio sample with the gender and age for each speaker. We manually transcribed our data samples to test the performance of a state-of-the-art automatic speech recognition system on RoDia dataset. There are 5 local annotators, 1 per region, who annotated all samples. The inter-rater quadratic weighted kappa score, it's 0.83, indicated that the collected labels exhibit a substantial agreement among human annotators. The average accuracy of our raters, it's 86%, indicated that the task is fairly easy for humans. Note that all raters are native Romanian speakers who speak the literary language, as well as at least one of the 5 dialects. Regarding the data samples, all of them have about 2.5 seconds and are acquired at a sampling rate of 44.1 kHz. Summing up, an WAV audio file have the dialect class, gender class, age class, and also a transcript. Now, let's talk about the results. We report the precision, recall, and F1 score for each dialect, among with overall micro and macro F1 scores. We conducted experiments on 4 state-of-the-art models: ResNet 18, AST, SEP-TR, WAV2, VEC 2.0. The best overall results were obtained by the WAV2 VEC 2.0 model. The best results are highlighted in blue in the table. The overall score can be seen in the right part of the table. Besides the results, we also added a confusion matrix. The confusion matrix of WAV2 VEC 2.0 shows that the training data distribution does not affect the model. For example, the Moldovenesc dialect is the second least popular dialect in our dataset, but WAV2 VEC places many of the test samples into the Moldovenesc class. The confusion matrix reflects the test data distribution, although the model was trained on a slightly different class distribution. This confirms that the imbalance does not affect models. Now, let's discuss the speech recognition results. We applied the open source Whisper Large model on our test set and obtained the word error rate for each dialect. The Muntenesc dialect is almost identical to the literary language, explaining why it exhibits the lowest word error rate. The word error rate obtained by the Whisper Large model for the Romanian language on the Common Voice dataset is 90.8%. Considering that the ardelenesc, bănățean, moldovenesc, and oltenesc word error rates are considerably higher than the results obtained by the Whisper Large model on the Romanian language on the Common Voice dataset, we conclude that the ASR for dialect speech is more difficult. In conclusion, we introduced RoDia, the first dataset for Romanian dialect identification from speech. Our dataset contains 2,768 speech samples representing 5 Romanian dialects. The audio samples were manually annotated with dialect, age, and gender labels, enabling the study of spoken dialect identification in a realistic scenario where the speakers in the training and test splits are disjunct. We conducted experiments with 4 state-of-the-art speech processing models, establishing a range of baseline performance levels for future research. Thank you for your attention. If you liked our work, please go visit and read the full paper. Also, you can scan the QR code to access our database.